and they were trickier than most of the graphs we've done, agree?
Yeah.
Yeah. So there were a lot more details, there were a lot more parts to it that we had to be careful of, like the asymptotes. And we're going to talk about other ways you can find the asymptotes, because it was kind of tricky to find those, right? Like you had to really look for them. And so I want to talk to you about how we can find those using algebra, and you wouldn't have to like scour your graph to figure out the exact spot where they happen. So we're going to talk about some important values that you can find just from your equation. So we're not going to graph again today. We're just going to talk about how you could find some of those values for your graph. So the first thing I want to talk to you about are zeros. So we're actually not going to start with asymptotes. We're going to start with this thing called zeros. So zeros are when the numerator, oops, I was going to write the word the again. The numerator equals 0. Do you remember that from the warm-up yesterday that I had you figure out when the numerator would equal 0 and then the denominator?
Yeah.
Okay. So zeros are when the numerator equals 0, and these are our x-intercepts. So if you were to look at your graph, right, so we have graphs, here's my x-axis and my y-axis. The x-intercepts are where your graph would touch the x-axis, so they would live along this line.
Okay.
So zeros are when the numerator equals 0, they're your x-intercepts, and so they would live somewhere along that line. All right, so we're going to find zeros first. So that's going to be kind of thing number 1. So you could even label this as like topic 1. We're going to talk about zeros. And then I believe I only did 2 for today. Yeah. So topic number 2 is going to be finding vertical asymptotes only. So there are 4 things you can find total. So we're going to talk about 2 of them today, and we're going to talk about the other 2 a different day. Okay? All right, so look at number 1. I only care about the numerator. I don't care about the denominator at all. There could be anything down there. There could be crazy numbers, there could be an elephant, there could be anything.
There could be a mug with a
Yes, there could be. Yeah, you guys weren't here earlier, so you haven't heard. I'll show you my mug that my daughter made and sent to school with me today for my coffee. It may haunt your dreams, but I will show it to you. Okay, so here is the numerator. It says x plus 5. It looks awful, but it's x plus 5. Okay. So I want you to look at just the numerator and think, when would the numerator be 0? So what value of x would make that 0? -5. And again, we can kind of just look at that one and eyeball it and see, but we can also like go through the solving process and say, let's subtract 5 from both sides. So this is my 0. This is also my x-intercept, because they're the same thing. So we can think of it as a 0 of the function or x-intercept. So on my graph, if I was asked to graph this like we were yesterday, I would have a point at -5. Okay, so that point would be somewhere on my graph. And you know we were struggling to find good points yesterday. So that could be helpful. All right, so the other 2. Again, I don't care about the bottom. I only care about the top when I'm being asked for zeros. Oh, hold on. All right, here we go. So when we go to these other 2, again, we only care about the numerator. We don't care about the denominator. So let's look at the numerator here. So we have x squared minus 9. And we want to know when it's 0. Do you remember when we did something called factoring and solving? A little bit? Okay. So we're going to factor and solve. This one is going to be our process. So give me 2 sets of parentheses, and hopefully the factoring is going to come back to us a little bit. Do you remember when we talked about a difference of perfect squares? Perfect square, difference? It is plus minus. Good. Okay. I love that. Do you remember what goes inside? Yes. And a number? Yeah, not 9. 3. Yes, good memories, guys. I love it. Okay, so you take the square root of this. So the square root of x squared is just an x. And then you take the square root of 9, which is 3. Okay, so now that we have these parentheses, what would make this one 0 if x were what?
-3.
What would make this one 0? Yeah. So this one has 2 zeros, or 2 x-intercepts, and they are at -3 and +3. So again, if we think back to yesterday and we're graphing, if I were graphing this, I would say, okay, I have a point at +3, and I have a point at -3, and those would be 2 points that would for sure be on my graph. Good morning. All right, look at the last one. The last one's a little bit different because when you look at it, it's not like the other two where you're like, oh, -3 would make that 0. Agreed?
I did not mean to do
That's okay. Do you agree you can't just look at it and think like, oh, this number would make it 0? So we're actually going to set it equal to 0 and solve it. So if you came across this equation out in the world, what would you do first to solve? Bring the 5 over. Perfect. So let's subtract it. So 3x equals -5. And then how would we finish getting x alone?
Divide by 3.
Yeah, good. You think about kind of how the 3 and the x are interacting. They're multiplied, and so we do the opposite, which is division. So this is my answer. It's not a nice answer, but it's an answer. And so that would be my x-intercept in this situation, or my 0. So we're learning about the graphs a little bit more in detail that we saw yesterday. The first thing I told them was that we're going to get 4 topics. We're going to talk about zeros. We're going to talk about vertical asymptotes today. So those are our 2 topics, or our 2 ideas for today. Zeros are when the numerator equals 0. Remember, mathematicians are in a creative group of people. So why do we call them zeros? It's when it equals 0. And specifically, it's the numerator. So this one, when we did this one, Demise, we just could look at it and tell, like, okay, -5 would make it 0. This one we had to factor, and I was so impressed with how well people remembered how to factor. And then this one you just helped us solve down. That one was a little bit trickier in terms of, like, you couldn't just look at it and see what would make it 0. Okay? So that's topic number 1. Topic number 2 is almost identical to topic number 1. That's the good news. Vertical asymptotes are when the denominator equals 0. And they are always in the form x equals. So when we write our vertical asymptotes, we have to write them as x equals. So topic number 2 is vertical asymptotes. How do I let you abbreviate that? Do you remember from yesterday? VA, because that's so much nicer than having to, that's a lot of letters. So again, you can say vertical asymptotes, you can say VA. I'm fine with either. So again, it's when the denominator equals 0, and we put it in the form x equals. So it does have to be in that format because it's an equation of a line. All right, so this time, I don't care about the numerator. So it's the opposite of number 1. So I only care about the denominator. There could be anything going on in the numerator. There could be animal up there. There could be broccoli. I don't know. It doesn't even matter, right? Because all I care about is the denominator. Let's start with this one. This one we can just look at and see. What value would make it 0? -12. Oops. I don't have enough room to shimmy in my negative. I'm going to put it right here. So x equals -12, and it has to be written x equals. This one. Do you see how this one is similar to number 2 up here?
Yeah.
So we can factor this into 2 sets of parentheses to help us figure out when it's 0. So what were the signs I needed to put in? Would you guys tell me about those? plus and minus. And then what should go first? An x. And what should go second? 9, because you square root the 81. And now we can play the same game. What would make this one 0? The set of parentheses.
Negative 9.
-9. How about this one?
Positive 9.
+9. And again, we have to write them as x equals. It's not a choice. All right, the last one. Can you eyeball it and just look and say, like, oh, this value would make it 0?
No.
No, like, you can't pick anything out. Like, -3 would get us close,
Yeah.
but it's hard to figure out exact values. So we're going to take 2x plus 7. We're going to set it equal to 0. And we're going to figure out, well, what value truly makes that happen. So what would you do first to solve this one?
Minus 7.
Minus the 7. So 2x equals -7. Then what? Divide the 2. So x equals -7/2.
I mean, that's not a number you would want, but.
Right, it's not the best number. We actually have a bonus notes packet today. So that's why you cannot find it. All right, so that's all we have for today. Are you ready to try a couple problems?
Sure.
Okay.